Week 3, we're moving into our last bit of the cardiovascular system. So we're moving into the vascular part. So remember that when we're looking at this system, it's all a big loop. So we had been focusing on this part here about the loop, the heart, and we're going to be looking instead now at the blood vessels. So with the blood vessels, oh, that's a horrible heart. But with the blood vessels, what we're going to find is that this is a series of vessels that lead away from the heart, right? Our arteries, leading down to our smallest blood vessels, which are our capillaries, and leading back up to large vessels again when we get up to our veins. So we'll find that there are multiple different types of vessels, and each of them is a good example of this whole relationship between structure and function, or anatomy and physiology. So you can see that there are elastic arteries and muscular arteries. Then we get down to these mini arteries that we call arterioles. And ultimately we get down to what we were talking about in terms of these capillaries. So when we get down to the capillaries, we find that these are very, very numerous and very, very small and very, very thin-walled, because this is where the exchange is going to occur with all of our different tissues. Then once we've done that, these are going to drain into very small veins that we call venules, and then those small veins are going to drain into larger veins that then go back to the heart to push it around again. So anything in this circuit is going to have an influence on the cardiovascular function. So whether it's an issue or something going on with the heart in terms of changing its activity, or something happening out here on the loop, that is going to affect the system overall. Okay, so as you're going through, one of the key aspects of this system, right, is that these are the organs, some of the organs of this organ system. Everybody talks about the heart, but of course the blood vessels also count as organs, because do remember that an organ is going to be defined as this thing that has more than one tissue type working together for a particular function. And whether we look at arteries or veins or venules or whatever, we will find that they have certainly more than one tissue type. If you look across their wall, like we're seeing across here, we see that there are multiple layers there, and each one tends to be a different tissue type. The innermost one is the tunica intima, then we have the tunica media, then we have the tunica externa. So these are going to be the same three layers regardless of whether it's an artery or a vein or arterial, etc. But what we have in each one of them, what they're made out of, the thickness of them, etc., will change. So for instance, if we look at the artery, it has an extremely thick middle muscular layer that we call the tunica media, especially compared to what we see in the vein. We also see that the veins have some specialized structures like these one-way valves that aid them in getting the blood back to the heart. And so each different blood vessel type, arteries, arterioles, capillaries, venules, and veins, has its own particular structure and function. So you definitely need to know that. How are they similar? How are they different? So that's what we spend a lot of time going through in terms of this chapter and this lecture. There's some good summary diagrams and tables that go through that as well. Again, table 19.1 goes through kind of when we look at the wall, again, how thick is it? So this is average diameter as well as wall thickness. And then what do we find inside of the wall? Is it this endothelial lining, elastic tissues, smooth muscles, or fibrous tissues? And you can see the composition changes depending on what type of a vessel we're talking about. Even with the capillaries will actually be different. For the most part, these are the simplest ones, right? These ones have an epithelial lining to it, right? An endothelium, if you will, and then a basement membrane, and that's it. So they don't even have all those three layers because these are nice and thin to allow exchange with the tissues. But in fact, there are different types of capillaries that are associated with how much transport we want going on. So there are continuous fenestrated capillaries, and then these things are called sinusoids. You can see they're almost looking like they're falling apart. They have so many holes in them allowing for transport. Okay, so we need to know different vessel types. We need to know their structure and their function. Now, we also get into what's called hemodynamics, which is like hydrodynamics, but it has to do with blood. So the blood vessels are about moving this blood through, but there's going to be some physics involved in terms of how easily it is able to push it from one vessel to another as they change diameter, as the structure of them changes. So when we talk about resistance or this opposition to flow, right, it's like it doesn't want to go along, and that amount of resistance can change depending on various factors. The viscosity, or how thick it is, the blood vessel length, how long it's dragging along those walls. But the main one that we actively change is blood vessel diameter, at least for those that have that middle layer, the tunica media, that's made up of smooth muscle, that we can constrict and narrow the blood vessel or dilate and open it up. So what we find is that by changing that diameter and using that, we can change the amount of pressure, we can change the differences in blood pressure that occur, etc. So like when we look at blood pressure that we see on the y-axis here, and we compare it to all these different blood vessels, you can see that the arteries get the most, if you will, abuse as the ventricles are contracting and sending this tidal wave of blood into these blood vessels. You're going to see this high point when there's a new tidal wave, and then a low point as it's passing by, and then back and forth and back and forth. But when you get to the arterioles, one of their main jobs is to protect those very small and very delicate capillaries. We're going to see the blood pressure go down, we're going to lose this pulsing sensation, and so by the time we get to the capillaries, we've slowed it down, we've reduced the pressure so that these things don't blow out, and we have time for things to exchange with the tissues before we move on further. Now notice that the blood pressure continues to drop because we're getting further and further from the heart, the pump, and we're having more and more drag as we go around this circuit. But ultimately, there's still going to be some pressure, enough to get us back to the heart and through our major our veins there. So that's where we see the key point where we are getting rid of this pulsing sensation right after the arterioles. So we need to know some important terms, like we said, systolic, diastolic, pulse pressure, mean arterial pressure. We'll get into these in lab a bit more when we get into the cardiovascular physiology lab, but you need to know those. We get into where you can measure blood pressure, again, more so in the lab, but you should know those for lecture. And then we get into this thing that's called cardiac output, a way that we can assess, ooh, that's a crazy line, a way that we can assess how well the heart is doing, how much fluid it's putting out, etc. So cardiac output, what we find, like we were talking about with the heart before, has to do with stroke volume, the amount you get in one squeeze, and then how many squeezes you get per unit time, right? So then when we look at blood pressure, it's also going to have to do with what's going on in the blood vessels, so this resistance, and how much blood volume we're having to push around. Now, one of the other things, once we learn about blood pressure, is how do we control it? When we need it to go up, when we need it to go down, we need to be able to change and control blood flow and blood pressure. And we've got various ways to do it. There are neural controls and hormonal controls. We're going to see that with every single system. Direct wiring that goes down and goes bzz, bzz, constrict, or bzz, bzz, increase your contraction if we're talking about the heart, right? Hormonal controls, hormones that go into circulation that can have effects that are usually longer term in increasing or decreasing. And that's a relative term, right? So neural, it's going to be split second, just like we see with, for instance, skeletal muscle. But hormonal, they go into circulation, and in fact, they can have influences over, minutes instead of seconds. Now, if you're talking about really long-term things, what we're talking about is control from the urinary system, because the kidneys are constantly monitoring and modifying the blood volume, the blood concentration, etc. Okay, so you need to know the different parts of the nervous system that control it and how it does it, both in terms of the heart as well as in terms of the blood vessels. So we've got, in any of these control systems, right, homeostatic control, we're going to have receptors, we're going to have a set point, that we compare it to, that information, and then we're going to have some sort of actual control mechanism where we have effectors that can produce an effect, a change if we need to. Okay, so what type of receptors we have, where are they located, what are they sensing? Those are all important things about how the carbon dioxide has an effect on this cardiovascular system as well. So we go through a variety of different control mechanisms. Talk about blood pressure, we're going to be doing this in lab, how we're measuring it, etc. What does it mean for systolic and diastolic? There are a number of diseases and disorders that in fact we do include in what we could be testing on. Oftentimes I just use them as examples of how it relates, how we are learning about how the body system does its normal type of activation and function, but then we talk about diseases and disorders and how it can malfunction. And oftentimes those diseases and disorders I won't put on the exam, but these are some pretty important ones that you hear about regularly and lots of people are affected by. So these ones that you see listed here, you should know about. You should know the different types of low blood pressure, high blood pressure situations. Okay, so we talk about pressure, we also talk about blood flow. We said that by changing the diameter of the blood vessels as it percolates through all these different blood vessels, it can affect both the pressure and the flow. So notice, like we said, it slows down to where we get to the capillaries, and that's going to be the slowest. Then it actually gains some speed again. Nothing like it was at the very beginning, but as we are dumping all the blood from these more numerous, smaller blood vessels into larger and larger ones, it tends to pick up speed again. Okay, so different types of control. Now, here's another major topic that you're going to need to spend time with, is that arteries, arterioles, venules, and veins are all about getting blood from one point to another, and that's it. But the capillaries are something different. We saw it in terms of their anatomy, has to do with their physiology. These vessels are all about allowing things to exit and enter the blood from the surrounding tissues. And so it's very important that you understand how these different substances are going to exchange. So it all depends on what we're talking about. If we're talking about gases or if we're talking about nutrients or something like that, there are a variety of ways that we can either do what we call transcellular movement or paracellular movement where we're going in between them. We can have different types of vesicular movement where we can actually very specifically transport one particular substance to get it across. So you need to know that diffusion occurs, osmosis occurs, these types of transport. But another important thing that you need to understand and spend time with is how these fluids are going to exchange with the surrounding tissue in this process that we call bulk flow, where things are going to, really tend to, never mind that arrow, move out at the beginning of the capillary and then move back in by the end of the capillary. So this has to do with opposing forces. At the beginning of the capillary, we've got a higher amount of blood pressure, hydrostatic pressure, that really is kind of winning this tug of war between opposing pressures, giving us a net movement out into the surrounding tissues, like you see here. But remember that as we drag along the vessels, there's going to be that resistance, and that's going to be taking this blood pressure down. We're also getting further away from the heart. So as that blood pressure goes down, the hydrostatic pressure that you see is HP, as that goes down, now some of these opposing pressures start winning out. This is what's called blood colloid osmotic pressure, the suction that comes from the different molecules like albumin that are contained within the blood. So by the end of the capillary, now when this hydrostatic pressure is kind of waning, now the osmotic pressure, at least the plasma osmotic pressure, is starting to suck these fluids back in. It gives us an exchange that occurs out of the tissues, and that's very important. We don't want to be dumping stuff in the tissues all the time. They would just swell up, right? We want to be able to exchange materials with the tissues. So bulk flow is certainly an important aspect, and exchange at the tissue levels. All of that is very, very important, so you want to take your time with that. Okay, So we talked about hypotension, hypertension. Shock is also an important state where the cardiovascular system is not able to do its job. So you should know the different types of shock as well. Now, a lot of the chapter has to do with different figures and drawings having to show you the different arteries and veins that you're going to have to know for lab. Not really important for lecture, but towards the end of the chapter it does go through comparisons of fetal circulation compared to the adult circulation. There are a number, as you see here in the boxes, of modifications between the fetal and the adult circulation, because in the adult circulation we know that we want to separate our deoxygenated blood from their oxygenated blood, so it's a very efficient system. But in the fetal circulation, number one, we don't have quite as high a demand, and number two, rather than having lungs that we're going to be exchanging oxygen and carbon dioxide with, right, we're inside of the womb, we're not actually breathing air. Instead, that exchange is occurring here with the placenta. And so as we do that exchange and we dump this blood back in, you'll notice it's already mixing with venous blood. So we have this kind of, as they show there, purple blood. That's a mix of oxygenated and deoxygenated blood. But for the fetal circulation, the fetal body, that's okay. So we've already done the exchange, so we're just trying to get this now newly oxygenated blood out to the body as quickly as we can. So we see the shortcut in terms of the foramen ovale between the two atria. We see the shortcut in terms of the ductus arteriosus between the pulmonary trunk and the aorta. And then, of course, we have some other shortcuts where we're routing via the ductus venosus this oxygenated blood back into the fetal circulation, and we have these vessels that are getting to and from the placenta in terms of umbilical arteries and veins. So you should know what these different structures are in the fetal circulation and what they do, and then what they turn into in terms of the adult circulation. There's some of my little circles highlighting all of those as well. Okay? All right, so those are some of the most important aspects of the vascular part of the cardiovascular system. One other thing that I'll show you that has to do with cardiovascular function. We'll see this in terms of a past episode of a show that was called Scrubs. All this new information you're learning can apply to your lives in all different ways. You can actually understand some of the shows that you watch on maybe a whole other level. Let's see how it applies here.
Brown Bear, thanks for spending so much time with me lately. I just feel like my whole life's in a crapper.
Oh, man, you'll turn this around.
There goes Buzz and Donna, off to the marriage counselor. Buzz feels inadequate because he lost his job at Foot Locker. Now his dingle won't work.
I should not have given you the spa equipment for your birthday.
Are you kidding me? I need it so I know when I can sneak over and use the can. And by the way, I'm using the front bathroom now because it has a hook on the door so I can hang up my pants.
You finally started listening to me.
You're right, my friend. Man is the only animal that wears pants during Tuesdays.
It's just so unnatural.
Nobody's test results came back. He's got vasovagal syncope.
And that makes you happy?
If he's vigorously Valsalva, he can activate his reflex and actually lose consciousness. Carla, he'll pass out when he poops.
Buzz? Donna? How was counseling? Would one of you mind handing me my chinos?
Turk, I need help.
Buzz is mad.
So see, there you go. That's a type of hypotension where you can actually pass out. Hopefully none of you have experienced that yourself, but it does come up, as you see. All right, so that is it for this week. We will talk to you again next week as we move into a new system.